Hi, welcome to this on-demand tutoring video from Apex Tutoring. This video is for Sam, and we are trying to answer the question for a finite math class for the Simplex method of how to maximize profit for a lawn and garden store. So we're given that the store makes different potting mixes, which are all sold in 20-pound bags. Mix A contains 12 pounds of peat, 5 pounds of perlite, and 3 pounds of organics, and makes a profit of $2 a bag. Mix B contains 10 pounds of peat, 6 pounds of perlite, 4 pounds of organics, and profit of $5 a bag. And mix C is 8 pounds of peat, 8 pounds of perlite, 4 pounds of organics, and a profit of $6 per bag. So the question is, what combination of bags should the store create to maximize the profit? So we're going to use the simplex method to solve this. And the nice thing about this simplex method is that you can very quickly zoom in on a solution. And in this case, it's only going to take us actually 2 steps once we set it up. Now, in our previous video, where we looked at the exercise regimen, we talked a little bit about how to set up the model, but we'll just kind of talk about this for a second, okay? We're going to say that variable x1 is the number of bags of mix A that we create. X2 is going to be the number of bags of B, and of course x3 is going to be the number of bags of C. And what we want to do is maximize the function z is equal to 2x1 plus 5x2 plus 6x3, z being our profit function. And the constraints that we are given is that we know that we have a certain amount of peat, so bag 1 will give us 12 pounds of peat per bag, or bag A rather. Bag B is 10 pounds, and bag C is 8 pounds, and the total amount of peat is less than 1,232 pounds. Similarly, for perlite, we have 5 from bag A, 6 from bag B, and 8 from bag C. That has to be less than or equal to 960 pounds. And finally, for organic material, 3 pounds in bag A, 4 pounds in bag B, and 4 pounds in bag C must be less than or equal to 680. So it really looks like the organic material could be something that limits us the most. Okay, so we're going to set this up and write the Tableau matrix again. And we'll set up our variables, x1, x2, and x3 for bags A, B, and C. And we need to have 3 slack variables, s1, s2, s3. And then we have z, and then our final column is for the coefficients. So we're going to start with our equation of our constraints, 12x1 plus 10x2 plus 8x3 plus a slack variable is less than or equal to 1232. And again, the slack variable of s1 is because we might have less than 1232. Then we have 5x1, 6x2, 8x3, a second slack variable, and 960. And then we have 3x1, 4x2, 4x3, a third slack variable, and 680 for organics. And then our profit function, remember we're going to take z equals 2x1 plus 5x2 plus 6x3, and we're going to write everything on the left side so that z has a coefficient of positive 1, but everything else will have negative coefficients. And there are no slack variables for this one because we have an equality. Okay, so in our last video we said that basically what we want to do is we want to take this diagonal right here for the slack, and we want to kind of move it over to our x1, x2, x3 variables. And the process of doing that is that we find the column that has the most negative number, and we take the ratio between our coefficient and those entries. So this would be 1232 over 8, which is 154. This would be 960 over 8, which is 120, and 680 over 4 would be 170. The smallest positive of those would be 120, so we circle that row. Oops, the whole row. And that tells us that the pivot number will be 8, the pivot entry. Okay, so we have to do a couple things. First of all, we have to divide that row by 8. So we have 5/8, 6/8, 8/8, 1/8, and 960/8 is 120. Okay. Then we need to figure out how to eliminate all of our entries from the column x3. So this is going to turn into a 1 when we're done here. And that means that we are going to have to subtract 8 times row 2 from row 1. Row 2 we won't do anything, that's the pivot. Row 3 we are going to have to subtract 4 times row 2. Oops, excuse me. And finally, we're going to have to add 6 times row 2 to row 4. Okay. So this takes less steps than the exercising example, but the math is a little bit messier. I'm going to keep things in terms of fractions. It's up to you what you want to do when you solve these, but you definitely want to use a calculator to check your work. I consider myself to be decent at mental math, and this was pretty challenging to try to keep all the numbers straight. Okay, so we are going to go again here, and we have x1, x2, x3, s1, s2, s3, z in our constant. Okay, and remember that what we're doing is we're adding -8 times r2 to r1. And what I suggest is, again, that you kind of take a look at the math and check, but we're going to have 7, 4, 0, another 0, -1, 0, 0, and 272. So for example, we took 12 and we added -8 times 5/8, which is actually -5 to give us 7. For the next one, we did 10 minus 8 times 6/8, so that's -6, which gets us 4. The whole key was to get that 8 out of there, which we did, and the rest of the row follows. The second row was our pivot, so we just rewrite that as is. And I can rewrite the 6/8 as a 3/4 now. I have a 1/8 right here, a 0 and a 0, and then this was 120. For our third row, we're subtracting 4 times r2, and that's going to land us with 1/2, 1, 0, 0, -1/2, 1, 0, and 200. So for example, I have 680 here. I'm going to be subtracting 4 times 120, which is 480, so I'm going to have 200 here. Another example is I have 3, which is the same thing as 24 over 8, and I'm going to be subtracting 20 over 8 to give me 4 over 8, or 1/2. So that's where those numbers come from. And then finally, in our last row, we are going to end up with 7/4, -1/2, 0, 0, 3/4, 0, 1, and 7/20. Now this is going to be what we want to keep an eye on. That's going to be our profit. So we took a big jump in that step. Okay, now it turns out that we only have one more step, but in terms of the math it's not too bad, but the algebra is kind of a doozy. We're going to select our column with the most negative number at the bottom row, which again is -1/2, and we're going to do our ratio. So we'll find that 272 over 4 is 68, 120 over 3/4 is 160, and 200 over 1 is 200. So the smallest positive number is 68. That is going to be the row that we'll focus on, and this is going to be the pivot element. And again, we are going to have to divide by 4 first before we can do anything else. So I'll just do it like this. And of course, 272 over 4 is 68. So again, in the gym one, we only had to divide once, but this time we've had to do it twice. It doesn't make it necessarily harder, just a bit trickier. That turns this into a 1. And now let's think about what we need to do to the other rows. We don't need to do anything to the first row because that is our pivot row. The second row, we need to subtract 3/4 times row 1 to get rid of that 3/4. Third row, we just need to subtract row 1. And the fourth row, we need to add 1/2 of row 1. So what is this going to turn into? Whoops. Let's go to our next slide. And again, x1, x2, x3, s1, s2, s3, z, and then our profit column. Okay, now we have our first row staying the same. That's our pivot row. So we're just going to write that down. That's 7/4, 1, 0, 0, -1/4, 0, 0, and 68. For the second row, we have to subtract 3/4 of row 1. So for example, we will do 5/8 minus 3/4 of 7/4, which is nasty. This is the same thing as 10/16, and you have minus 21/16. That is going to give us -11/16. Okay? The 3/4 is going to go away. That's the whole point of choosing 3/4. Okay? And this 1 right here is going to stay a 1 because we're subtracting 0 from it. And then everything else in this row is going to be 0, 5/16, 0, 0, and 3/4 of 68 is 51, right? Divide by 4 is 17, times 3 is 51. Subtract that from 120, and this is going to be 69. Okay? Now, our third row, we are simply subtracting row 1, so that's going to turn into -5/4, 0, 0, 0, -1/4, 1, 0, and 132. And that was because we had 200 minus 68. All the others, I'll let you just take a look at. For example, -1/2 minus -1/4 is just -1/4. Okay. And now our last row, we're going to do 7/4 plus 1/2 of 7/4 is 7/8, which actually gives us 21/8, which is positive, then 0, 0, 0. This will give us 5/8, 0, 1, And then 720 plus a half of 68 is 754. And believe it or not, we are done. Now the reason that we are done is that there's no more negative numbers in this last row. So this tells us that this is a maximized number. And anything else that we do, similar to the first couple of steps, is actually going to reduce this number here. And we don't want to do that. Okay? And that's just a factor of if I wanted to eliminate one of these numbers, I would have to be subtracting things from it, and so this number would go down. But this tells us something very interesting. This tells us that x1, which is the number of bag A that we have to create, is actually 0. Okay? Because we're looking for a 1 in this column to correspond to number of bags in this column and profit right here. So there's 0 bags of bag A. This means that we want to make 68 bags of B, and we want to make 69 bags of C. Now it's worth checking this to make sure that it makes sense. Okay? For example, we have the constraint that our organic material has to be less than or equal to 680. And we had the equation originally 3x1 plus 4x2 plus 4x3 must be less than or equal to 680. And so if this is a reasonable solution, then we have to take 4 times 68 and add 4 times 69 and see what that is. So that's actually going to be 548. 548 is indeed less than 680. And it turns out that if we just try to add more of this bag but less of another, that would actually decrease the profit. So this is our final answer. 0 bags of A, 68 bags of B, and 69 bags of C for a total profit of $754. So I hope that this has been helpful. Please don't hesitate to send us any of your questions in the future, and thank you for watching.